Hello and welcome to the Sidewinder YouTube channel. My name is Ray, and in this video, SpotMicro Part 8, we're going to start with the operating system and my robot lab. So in the previous 7 videos, I built this SpotMicro robot dog, including the stand that he's currently sitting on. One of the things I have done that I didn't show in the videos is I made a cable up with a battery plug on the end to plug in the power supply to emulate the battery. I've unplugged both the batteries that's in his bottom, and I'm using that cable to connect to my power supply for the purposes of programming. It turns out that with a Raspberry Pi 3 that I currently have installed, setting up my robot lab on it and downloading all the updates for the Debian Linux or Raspberry Linux that we're running takes quite a considerable amount of time and would exceed the capacity of the batteries. So for that reason, I've added in this long cable, and that gives me an opportunity to, test it out and make sure everything is working fine. Alright, so the first thing that we really need to do is copy the image that we download from the Raspbian website and put that onto a MicroSD card. So in this case, I've got a choice of the operating systems that I can use that I've downloaded over many years now. The first one that I downloaded ages ago was Stretch, and you can see I've got a Stretch image there. The one I've been using most recently has been Buster, and you can see I've got versions of Buster. Ignore the OctoPi ones, they're for the 3D printers, and they include Octoprint. The one I've just recently downloaded is Bullseye, and I found this. Look, I haven't tried Bullseye before. I don't know what it's likely to do, so I've downloaded it. We'll give it a try. Now there are 3 versions of it. There's the light version. It doesn't have a desktop environment at all. These are good for headless operations where you don't need to remote in with any sort of graphical user interface. The Bullseye ARM HF Full is a full desktop environment. If you are going to be using the Raspberry Pi as a small computer, then that's the one you want to go with. It's got most of the apps that you're likely to need installed on it. The one I'm going with is the Raspberry Pi Bullseye ARM HF. I did download that at the end of last month. So we're going to select it. Make sure you select the right device you're using. I am using this 31.9 gigabyte USB, and then we flash it. Now in my case, Windows did pop up a warning that I'm going to be making system changes, something about formatting a hard drive, but we're going to do this anyway. Okay, so that's now done. I'm not going to flash another one, so I'm just going to close that out. One of the things I found that this version of Balana, which is I think the latest, does is it unmounts the MicroSD card ready for you to pull out and put into your robot. The problem is I don't want to just yet. I want to make this a headless install, so I've just removed the card and put it back in. Now Windows is going to complain about one of the 2 partitions it makes on the MicroSD card. So let me just bring this up. So I might just resize this a little bit so it fits. Okay, so it creates two drives, or two partitions, one of which it calls boot. In this case, it mounted on my computer as M. It could be any drive letter on yours, depending on what other drives you've got. So there's three things that we want to do in here. So I'm going to go in here and edit the config.txt. I'm going to use Notepad this time. Don't use Word, don't use anything like WordPad, because they will butcher the file. We really don't want this file butchered. This is a Linux specific file and it has to be done right. Okay, so a couple of things we need to change in this file, this particular file, which is config.txt. We want this HDMI force plug. We need to remove the hash in front of it. This HDMI group equals 1 and HDMI mode equals 1 we need to change. The number for HDMI group needs to be 2 and we need to use 82 for the HDMI mode. Now the other thing that we found through experimentation, I'm actually going to turn on this I2C. Okay, so in here we've got DT overlaid VC4-KMS-V3D. We need to comment that out along with max frame buffers equals 2. Now, while this isn't normally required for a standard build, if you want anything over a 640 by 480 screen when we eventually connect using VNC, you definitely need those ones turned on. Oh, those commented out. That one's kept many people caught out. Okay, so that'll do with that one. I'll save and close that. Now the other thing I need in here to connect to this headless, we need the SSH server enabled to allow a connection. And this is actually easy. We create a new text document. We call it SSH in uppercase. And we delete the extension. Windows will complain about it. Are you sure you want to change it? Yes. And that will just enable the SSH port. And with the SSH port enabled, we can now log into it remotely with an SSH client. The SSH client I will be using is called Putty. Okay, so the next one that we need to create, I'm going to create another text document. Just before I do, I'm going to look up its file name to make sure I get it right for you. So this is a complex one. So new file wpa_supplicant.config and get rid of that .text. Yes, I want to change it. Alright, so open with more apps, Notepad. Okay, so what we need to do is add into that the information Linux requires to connect to a Wi-Fi network. And that's this one. Now for country, select your country standard 2-letter code. So if you're in the US, it'll be the US. If you're in the UK, you can select the UK. There is a list on the Raspberry Pi website as to what all these codes are. You'd have to search for it because I don't have a link handy. But I'm in Australia, so I'm using AU. Now the next part I am going to blur and skip over a little bit because I'm not wanting to put my Wi-Fi details on the internet. But set up the name of your Wi-Fi link. I'm using my mobile phone to get the detail. Check and make sure you type it in correctly too, because if you don't, it doesn't work. And it is case sensitive. Okay, so once you've done that, save it, and we can exit out of there. So there are all the files that we need to change, modify, edit. So now we can eject that. Right. So the next step of the process is to install that. And then once it's installed, power up the robot and connect to it with Putty. Now I do have Putty installed on my system. There will be a link in the description to get it. So if you set everything up correctly in your files, when you boot up, you should be able to connect using that. I've just got to put this MicroSD card back in the robot. So I've got my power supply connected to it. The switch is on. All I have to do is enable the output. So I'll turn it on. So my robot has lit up. And we just need to give it a minute to boot. So I've pre-configured my router to always give this the same address. So I'm just going to ping the address I know it's going to come up as. And as soon as it's come online, I'll be able to look at it. You can actually ping, here we go. So you can actually ping that same address I typed into Putty. So ping raspberry pi .local, and in this case it comes back with an IP6 address, which the latest version of the firmware supports. So I'm going to SSH in, make sure you select SSH and open. Now it is going to pop up a security alert. You need to accept that. And then you can log in as Pi. And the password on first boot is Raspberry. Now that we've logged in as Raspberry, we need to use the super user commands, sudo raspi config, and that gets us to our configuration system. Now the first one that we're most interested in, or at least I am, is this VNC, and I'm going to set it to yes. That allows me to connect using the VNC on a graphical user interface. While I'm in here, let's just have a look and see what else we need to turn on. Now, in theory, I2C should already be on, which it is, because I set that in the config.txt. We also have the camera, which is on by default. Now I'm using the serial port, so I want to enable the serial port. And remote GPIO I'm going to turn on as well. one of the other things I'm going to do, because you may run multiple Raspberry Pis on your network, to find the right Raspberry Pi each time, it's good if you don't leave a Raspberry Pi with the name Raspberry Pi. So under System Options, Host Name, I'm going to change it. Okay. That should be all we need to worry about at this time. Would you like to reboot? Yes. Alright, so it has actually gone down for a reboot. Okay, to confirm that our Raspberry Pi has come back up, we can ping its address. So I changed it to SpotMicro, so it's spotmicro.local. And yes, it has come back up. So now I'm going to launch VNC. Now it will pop up a warning about the address. It's not recognized. You haven't connected to it before, so it's not going to be recognized. So click on continue. It will ask you for your username password. So again, Pi and Raspbian. Raspberry, sorry. Okay, so once it's up, we can go through the process of setting up. Okay, so it does want you to change the password, so I'm going to set a new password. Well, everything looks alright. I am doing this remotely. Most of that's to do with HDMI anyway, which we're not using. I'm going to skip this because we've already got Wi-Fi connected. And it's a good idea to do next on that one, and it will update all of the software. Okay, now that that's finished doing its update, it wants to do a restart. So I'll be back after the restart. Okay, so now that this has started back up again, time to install a few other services and programs that we need. Let's start with sudo apt-get update. Should be pretty much up to date. Right. Upgrade should also be pretty much up to date, and it is. So sudo apt-get install. Open JDK 11 JDK. Yes, I do want to install this. So this is the version 11 Open Java Development Kit. I think they're up to about version 13 or 14, maybe higher. But after about version 12, things start to break. So we'll stick with Java 11, which the build of Nixie is targeting at this point in time. If you're wanting to install Manticore, which I'm not recommending on a Raspberry Pi, then you will need Java 1.8 or more Java 8 as it's more commonly known. So this will take a little bit of time. Okay, now that's installed. The Java 11 OpenJDK had an issue with the sound when working with my Robot Lab, and what it is you can configure your robot Raspberry Pi to use the external sound jack or a HDMI or any other sound device you might have, but Java will always use the HDMI for some reason. This is something to do with Pulse Audio. So we get around that issue by editing the sound properties configuration file. So in this case we need sudo now where was it? It's in etc Java 11 OpenJDK sound.properties. Helps if you edit it. Okay, so in this file we need to add some lines onto the end. Adding these lines on will tell to use the original sound samples ports. This list will be in the description, so you can copy and paste just as I did. Control O will write it out, and Control X to exit. Now, recent events, the guy who actually wrote Wiring Pi, very smart fella, was getting a bit of flack because he wasn't updating for different versions of the likes of the Pi or when the latest version came out. So he's gotten all upset and pulled it. I did, however, find a fork that somebody had copied on GitHub. So we need to get that down because it's no longer in the repository. Once we do that, we cd into wiring Pi and /build will make it build the Wiring Pi library. It takes a little more effort now to do it compared to what we used to have, but yeah, when you have a developer being picked on because he's not doing it fast enough and he's not being paid to do it, he might just say, well, go do it yourself, which is what we're having to do. So always look after your developers. Just as a side note, there is actually a Patreon account for My Robot Lab if you'd like to support My Robot Lab down the track. I've been a supporter for quite some time, and My Robot Lab is continuing to be developed and come along quite well. Alright, so the next thing we need to do is actually download My Robot Lab itself. So I'm going to actually open up a web browser. So www.myrobotlab.org. So this is a non-profit group. All donations they receive are used to run the likes of the AWS server, which distributes all of the code and holds the website. It's currently building a new one, but the latest successful build was 668, so we're going to download it. I believe the new one that they're currently building has a bug fix in it for the ultrasonic sensor, but I know 666 worked for the most part, and there's just been some user interface upgrades in 668. If you'd like to keep up to date with what's going on with MyRobotLab, they do have a Discord server, and I'll put a link in the description for that as well as the Discord link for my server. And it's down. So I'm going to close this because Chromium is a bit of a resource hog. And this will be in downloads. Right click on it, extract it. Here will do. Cut it, go back to the Raspberry Pi, and I'm going to paste it there. And then I'm going to rename it to what is going to be easier for me to type. CD MRL 1.1.668. Incidentally, this is the first time I've installed this particular version. Alright, for those not familiar with Linux, ls is the equivalent of directory. And you'll find that there are 3 files. The one we want to run is myrobotlab.sh. And if I was smart, I would have told it where to find it, which is in the current directory. Right, this will take some time, so I might come back when this is finished doing its install. So first time you run this, it will do a full install. Okay, so this is finished installing. MyRobotLab was designed to run multiple different types of robots. There is a large focus on the InMove robot, and you'll find more information following that link. Runtime is where we can launch various different services, and there are a lot of services within the MyRobotLab system, as you can see on that list. I'm not going to go into running MyRobotLab in this video, it's beyond its scope, but you can use this set of instructions to install MyRobotLab on a Raspberry Pi for any type of robot. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my VIP Patreons Go Lucky and Lorenz Berger, or my other Patreons Elmerellis45 or Ratchet. All my Patreons get these videos at least 2 weeks earlier than YouTube. You can also find a link to the Discord server down in the description. You can join the growing community talking about robots, 3D printers, and anything else that happens to come up. And we'll see you in the next video.